This video is about a quick overview about metamaterial measurements. In most of the publications, you may have seen the results like this, which showing the polarization and angular stability. So this plot shows the polarization stability. So here you can see that how the polarization angles are changing and how the results are obtained. And this shows the angular stability for TE and TM polarized wave. Here you can see that how the incidence angle are changed and the results are obtained. So this video explains how these plots are obtained in anechoic chamber measurements. This is the common setup for the measurement. It should have a transmitting antenna, receiving antenna, and both the transmitting antenna and the receiving antenna has the capability to rotate from minus 90 degree to plus 90 degree. Both the antennas are connected to the vector network analyzer, and this antennas should be able to rotate from theta 0 to 90 degree. That is, this antenna should have the rotation capability, and there is a target holder where we are putting our periodic structures. So this rotation allows us to take the angular measurements, and this rotation of the antenna allows us to take the polarization measurements. For a normal incidence measurement, we will be putting both the transmitting antenna and the receiving antenna at 0 degree position. And first we will take a metal plate as of the same size as the periodic structure, and we will take the measurement on the network analyzer. We will normalize it, then replace the metal plate with the structure, and we will take that measurement. That will be the response from this periodic structure. Why we are using the metal plate is it is the calibration step. That's why we are using the metal plate as the reference. So this is for a normal measurement setup. This is the measurement setup at Department of Electronics, QSAT. Here you can see that both the transmitting and receiving antennas and the target holder, and it has the capability to move. These antennas has the capability to move from minus 90 degree to plus 90 degree. And by adjusting here, we can also rotate this antenna for the polarization measurements. So let's see how the polarization stability measurements are done. Here you can see that performance of the structure is measured for different polarization under normal incidence. That means we have to put both transmitting and receiving antennas here at 0 degree, and we have to first, for all the measurements, we have to take we have to put the metal plate here and take the measurement as the reference, and based on that we have to take all the measurements by putting our target, that means our periodic structure here. So by polarization, it just means that the alignment of the electric field. So if we consider the horn antenna, we know that this is the orientation of the electric field. So this means that if we are putting both the antennas like this, we know that the electric field alignment is along 0 degree direction. So we call it as phi equal to 0. If we want to make the phi equal to 30 degree measurements, we have to rotate this antenna along 30 degrees. So you can assume how the electric field will be rotated 30 degree. So that's how we are doing the polarization stability measurements. So we will be putting both these antennas here, and we will be rotating these antennas from 0 to 90 degree to take the measurements. So if it becomes 90 degree, we can see that it will be 90 degree oriented with respect to this. So if it is 0 degree, the electric field alignment will be like this, and if it is 90 degree, the electric field alignment will be like this. So these are called as TE and TM mode in CST simulations. So this does not has any relations with the T and TM mode propagation in waveguide. It just indicate how the orientation of electric field is. So here we are always considering the plane wave, and this TE and TM in CST simulation just indicates how the orientation of electric field is. So this is how we are doing the polarization stability. So this is the angular stability plots. Here you can see that the angular stability plots are done for both TE and TM polarization. So here you can assume that the antennas will be aligned with electric field along this axis, and these antennas will be rotated along this arc to take these measurements. And for TM, these antennas will be rotated, and then they will be rotating along this arc to take these measurements. And one of the important things that you have to notice is, because we are taking the metal plate as the reference, so in case of a metal plate, we know that the angle of incidence is equal to the angle of reflection. So if we are putting the transmitting antenna here, we have to put the receiving antenna here. That is the only thing we have to taken care while using the angular stability measurements. So this is how we are doing the polarization and angular stability for the metamaterial structures. Thank you.